Our goal is to implement the EveCore microcontroller in Verilog. In order to make sure it's working correctly and to debug it as we go, we're going to need to see the internal state of the core. And so the question is, how in the world are we going to look and know what's going on inside the core as it executes? So here is the FPGA board that we're going to be targeting. And as you can see, it's got a 7-segment display with 2 digits, which is only enough to display a single byte. And it's also got 4 push-button switches, as well as 4 LEDs. There's some pins for digital I/O, and there's also a VGA connector here, but we're not going to use the VGA or these digital pins. It's going to be rather challenging to see what's going on inside our FPGA with such a limited interface here. So let's see how we're going to do this. First of all, we're going to use this button here for single stepping. So here we single step, and then we're going to use the LEDs to show what state the state machine is in. So you can see we're stepping through the states. The display is showing by default the value of the instruction register. So we can see the opcode of the instruction that's currently being executed. And then to reset the whole thing, we're going to press all 3 buttons here and then single step it. And so now we're back to the beginning of this program. We're going to use this to show the program counter. So if we single step it, we see the program counter is advanced to 1. We single step it again, it's now at 2. And we single step it again, and it's now at 3, and so on. Then we can use the other buttons to see particular values. So we can also use them in combination. For example, we can press 2 buttons simultaneously to see one value, like that. So we can get several different bytes of output here, and typically we'll use button number 1, the upper left-hand corner, to show what's in the A register, maybe, and this one here to see what's in the B register. But these we can change from time to time as we modify our Verilog code. But that should give us a way to see the things that are important. We can see the program counter, the current instruction, and we can single step things. Okay, so now let's take a look at the output control module, which is what makes all this happen. This module controls a 7-segment display. It takes several data bytes as input, and it displays whichever byte is selected by the push-button switches, and that allows us to examine more internal state than we would otherwise be able to do. So it's purely combinational. It takes the inputs and it computes the outputs with no internal state, so there's no clock input. So for example, if we press, say, switch 3 alone, the 2 digits would display the byte that's called data 3. We can also use them in combination. So for example, when the top 2 buttons are pressed, we would display whatever the data 5 input is. And so here are our 4 buttons as input, and then for each of the digits in the 7-segment display, we have the 7 lines that will drive each of the 7 segments in the display. So this module is pretty straightforward. It has a case statement that looks at the switch values, and based on that, it determines which one of the 8 data bytes to display. And so, for example, if switch 3 alone is pressed, that would be 0010, we would be displaying the value called data 3. And then once we've selected the value to display, we have 2 instances of the 7-segment decoder module. The first segment looks at the most significant bits of the value to display and converts them into the 7 different lines that control the 7-segment display. And the second instance looks at the least significant 4 bits and produces the second hex digit. And so let's take a quick look at the 7-segment decoder module that's shown right here. And you've probably seen this before. It takes a 4-bit nibble and it produces the 7 lines to drive the output. And you can work through all these combinations here, but it's just a case statement looking at the current input value and determining which segments should be lit up. Now we're ready to take a look at the top level, and this shows all of the input and output pins to the FPGA. Of course, we've got our clock input, and here we see the 4 buttons as input to the FPGA. Here we see the 4 LEDs, and here we see the first segment of the 7-segment display, and here we see the 7 lines of the second digit of the 7-segment display. And finally, we see the UART transmit and the UART receive lines, and these are the lines that are sent to the asynchronous serial communication device. Now let's take a look at how we instantiate the output control module. First of all, for each of the hex digits, we've encapsulated the 7 lines into a bus called hex digit 1 and hex digit 2. And here we are associating the 7 pins that are used on the FPGA with this bus and with the hex digit 2 bus. And then we've got several signals coming from the core that we want to display. In particular, we want to display the program counter. Actually, we'll only be concerned with the least significant byte of the program counter, which itself is 15 bits, but we'll just look at 8 bits of it. We've got the current value of the instruction register, and that's a 8-bit opcode that's currently being executed. And then we have the current state of the finite state machine. We'll only need 4 bits for that. And we've got the next state as well, which is also 4 bits. And then finally, we've got 2 additional items to display, which we'll just call miscellaneous out 1 and miscellaneous out 2. Typically, we'll display the A and B registers in the 1 and 2 positions, but we can display other things like the different registers or whatever. And so here is how we are instantiating the output control module. We see that we are simply wiring the 4 switches to the switch inputs of the module, and we're taking the output of the module, the 2 hex digits, and we're routing those to the appropriate pins on the FPGA. And then for the 8 possible inputs that we can display, we are using what comes from the core module. And in particular, when no buttons are pressed, we'll display the current value of the instruction register. This is the opcode that's currently being executed. We will also be using switch 4 for single stepping, so whenever switch 4 is pressed by itself, we also want to continue to display the instruction register. So basically, when we single step, it won't affect the display. We'll just be displaying the instruction register. But when we want to look at, say, the program counter, for example, we can press switch 2. And if we want to look at the current state and the next state, we can press the top 2 buttons. And then when we press the top left button, we would see the miscellaneous output 1. Again, it could be the A register. We'll change that around as we're debugging our core. And then when we press the upper right-hand button, we'll display whatever miscellaneous output 2 is. And for the other combinations, we're just not really going to use those. So we'll just display some random values to make sure this module is working. Okay, so that should more or less complete the explanation for how we are getting output that we can use while we're debugging our core. So I think we're ready to move on to another module.